Assalamualaikum. See you again in next video. Same chapter 4, but before that, let me brief you the final examination on this coming 2 December, 2 p.m. 1 hour midterm test. We are supposed to have tests on last week, but because of the study week, then the test has been postponed or shifted to this week. I'm not sure your preparation, but based on my observation on the YouTube view, I can conclude that your preparation is not that good, because the YouTube video is very low based on the view. I'm not sure, maybe you make a revision based on other video or based on different resources, but please, for the test, please do preparation by watching the online class video, look at the test, look at the slide, right? Okay, it's very brief about the midterm test, because this is online, so maybe it's not that tough as physical examination. But if you don't prepare well, you may not answer correctly. Okay, so please at least watch my video, try to understand. Some of the videos is not in good voice, but try to volume up and listen it carefully. Try to understand from the slide, from the video. Okay, so this midterm test covered from chapter 1 until chapter 4. Some questions in a format of direct answer, essay, but you don't have to make any attachment. Just answer all the question in the column. Okay, no need attachment. There are a few format, multiple answer, true and false, direct answer, and also you have to answer in the given space. Okay, there are a few sets of questions. So if you plan to copy your friends, um, don't do it. Okay, unless don't do it. All right. Try yourself. Prepare uh, any materials. If you because this is online, so you can make yeah, you can refer to any notes. Okay, so what you need to focus is chapter 1 until chapter 4. Okay, okay, let me open the wait a minute. Let me check the questions. Okay, there are two questions, 1 hour. Okay, total marks is 60, 18, 20, 35, 35. 35 marks. So on the chapter 1, is general knowledge of computer vision system and application also. Okay, you need to discuss the application of computer vision system. If you want to make a discussion on this application, I would like to advise you to go to a very specific explanation. I mean, don't explain in general. Go to the very specific application, detection defect, right? Something like that. Not just discuss in general. Okay. In chapter 2, for chapter 2, you have to understand how to about the image formation, grayscale, conversion, you know, uh, RGB to black and white, gray image. So that is the number 2 question number. I mean chapter 2. Okay, not this one. Okay, so next is color segmentation. This is in chapter 4. In chapter 4. Chapter 3 is image enhancement. Okay. Chapter 4, color segmentation. So try to understand the example in chapter 4, color segmentation. Try to understand how how to select face, for example, face region, an apple. Okay. Yeah. Yeah, I think that's all. Chapter 1 until chapter 4. 1, 2, 3, 4. Okay, you have it's Monday, Tuesday, 3 days to go. Okay, please take it seriously. Although this is online, you can open books, go and find answer in the internet, but please make preparation as well, because at least you have some knowledge on this chapter 1 until chapter 4. So if you need any clarification, then you can refer to notes during the test. It's not find the answer during the test without any preparation. Okay, so hope all the best to you for this coming Thursday for midterm test. All right. So let me finish this chapter chapter 4. Because some of the video that I uploaded in the YouTube, the quality is not so good. So let me explain it again. Okay, so this is chapter 4, segmentation. Chapter 4 part 1, we learn the color segmentation. So this is also the same segmentation. So if you go to the Matlab, this Matlab demo, then from there you can understand how important or how to perform a segmentation, image segmentation. Because when we do the image processing, colors segmentation is very important, because we want to analyze the region that we interest, they call it region of ROI. Because in one image, in one image, when we perform image analysis, we want to analyze some of the object that we use. So one way to do that is by image segmentation. So this is the example. Segmentation attempts to partition the pixel of an image into groups that strongly correlate with the object in an image. So this is first step. Okay. So for example, this one, this one, this one, this one. So when we perform image segmentation, we want to process only this area, So this is one way to perform a segmentation. So for example, this one, we want to analyze this object, this one, and we have to perform segmentation like this. So this one, perform segmentation. Okay. So this is a detailed step of segmentation because the segmentation, we want to find a similar area of the object, then we segment. So there are three basic types of grade level discontinuities that we tend to look for. So discontinuities. So discontinuities is contributing to the segmentation. So one way to find a continuity and discontinuity is by points, lines, and edge. We typically find discontinuities using mask and correlation. So this is point detection can be achieved simply using this mask. Okay, if you have one image, we can use this mask to find point. We amplify the pixel, then we attenuate the neighbor. So we will get a point. Points are detected at those pixels in the subsequent filter image that are above a threshold. For example, we want to find this point, define a stray image of a turbine blade. Then we perform some image enhancement. Result of point detection, we perform a segmentation. Then we set the thresholding and we get this point detection based on the thresholding. Okay, so that's the segmentation. Next is a line detection. So this is the mask that we can use for line detection, horizontal, vertical, 45 degrees. The mask below will extract lines that are 1 pixel thick and running in particular direction. So this is the example of line detection. Next is edge. An edge is a set of connected pixels that lie on the boundary between two regions. So this is edge now. When there is a different pixel value, then we see the edge. Okay, this is also edge, but the pixel value is gradually changed, not drastically changed like this. So, but this is also edge. This is also edge, but this one more easy to detect the edge compared to this one, because here you don't know where is the exact edge border. Okay, so this is edge and derivative. This is more details on the edge. Okay, so this is a common edge detectors. Given a 3x3 region of an image, the following edge detection filter can be used. So Privet, Sobel, Roberts. Right, this is a type of mask 3x3. When you use this mask, then you can detect it. Very straightforward and very simple algorithm. Original image, horizontal gradient component, vertical gradient component combined, and then you get this line here. H. Okay. Often problem arise in edge detection in that there is too much detail. When you perform edge detection, sometimes it gives you too much detail. You don't want too much detail. For example, the brickworks in the previous example, one way to overcome this is to smooth image prior to edge detection. We perform smoothing first. Original image. So this is the another method of age detection, Laplacian age detection. Okay, this is the mask, the algorithm. Okay, there are a lot of method of age detection, but you can use it by using software like Matlab. But the most important age detection is detection of different pixel value at in the image. Okay, so you can use like software private, Roberts, or any kind of algorithm available, uh, which has been created by someone, and we just use it. Okay. Next is segmentation. Image segmentation divides an image into its constituent regions or objects. Segmentation of image is a difficult task in image processing. Segmentation allows to extract object in image. Model-based object extract template matching. Okay. After successful segmenting the image, the contours of object can be extracted using age detection or border following techniques. Shape of objects can be desired. Based on shape, texture, and color, object can be identified. Segmentation algorithms are based on one of two basic properties of color, gray values, or texture. First category is to partition image based on abrupt changes in intensity, such as age in an image. Second category are based on partitioning on image into regions that are similar according to predefined histogram. Okay, so this is an example. You want to partition the color, or you want to segment the flower. Okay, the object can be distinguished by assigning an arbitrary pixel value or average pixel value to the pixel belonging to the same cluster. We can perform segmentation by thresholding. Thresholding means that we set a certain pixel value so that we can segment the object. So this is an example. We have a histogram here based on the image just now. There are two distribution of pixel value. So based on this pixel value, we can perform the segmentation. Okay, we remove the background. We remain the thumbprint, because this is the object we want to process. So in Matlab, histogram for image can be constructed using the image cont. So this is a histogram. Okay, so this is more detailed. If you look at this grayscale image price with background, this example, you can refer to Matlab based on histogram. So we can perform a segmentation based on histogram. So we remove some of the pixel value based on the histogram. So by looking at this, by looking at this histogram, we can understand that this is the background, this is the rise. So if we remove this one, we get the black background. I mean, we change the pixel value of background into black. So the object that we interest, we change into 1. So this is more clear, or this is the segmentation image. So there are a few methods of thresholding, adaptive thresholding. So you can refer to this Matlab coding for image segmentation. Okay, so this is more detailed segmentation. So just look at the slide. a lot of methods or techniques we can